Hey guys, how are you? A very good morning to all of you. In our last video, guys, we have studied about the work power energy, that is the second chapter of class 10 physics. But in this video, we'll study the mechanical energy and its form. So have you remember my last video? One thing I have said regarding in the face of doubt, take action anyway. Yes or no? So I believe you should have taken action. I mean, you study sincerely and seriously. So let us proceed further. So mechanical energy, there are two types of mechanical energy. One is, I can say, potential energy, and the other is what? Kinetic energy. The potential energy is when the body is at rest and at a height, at any height h, and the kinetic energy is when the body is in motion. So the total energy means what? Total energy, I can say, is what? The potential energy plus the kinetic energy. Yes or no, guys? This is what the total energy. So the energy possessed by a body at rest due to its position or size and shape is called the potential energy. Remember this, okay? For example, I can take a body placed at a height above the ground level, okay? Wound up watch spring or a stretched rubber, etc. These are the example of what? Potential energy, okay? So as I already have said, kinetic energy is what? When the body is in motion. So now the different forms of potential and kinetic energy, let us study. So there are three types of or three forms of potential energy. Those are, first is gravitational potential energy, I can say here, gravitational potential energy. Next is your elastic potential energy, and the last one is gravitational potential energy at a height h. Okay, so gravitational potential energy is due to the force of attraction of earth, okay? And elastic potential energy, it means in a rubber, if we stretch it or we compress it, in both the case the energy is being stored in the spring, is what known as the elastic potential energy. And the next is what? Gravitational potential energy at a height h. Now the gravitational potential energy of a body at a height h above the ground is measured by the amount of work done in lifting it up from the ground to that height against the force of gravity. Okay, now let us assume, let us you throw a ball from a ground level to a height. This is a ball, we have thrown it from the ground level to a height h. Okay, this is the height h. So what is the amount of work done? Is nothing but the potential energy. So we know that work done is equal to F into S, force into displacement. So what is the displacement? Here is h, and what is the force? Is what? Against the gravity. So mg is the force and this is the h. So W is equal to, or which is equal to U, potential energy is equal to mgh. As you know, here the potential energy depends upon the value of what? H. Yes or no, guys? So h is what? The height of the body. Okay, see, so this is the different forms of potential energy. Now what is kinetic energy? So kinetic energy is equal to half into mv square. This is the formula of kinetic energy. The proof is already given in the book. You should go through the book, and if you have at all any doubt, please let me know about the doubt in the comment box, guys. Okay, because if I'll try to prove the how it comes half mv square, it will take a lot of time. Okay, so for time being, you remember the kinetic energy is equal to half mv square. Okay, since it is depends upon the velocity, and the potential energy depends upon the what? Height, mgh. Yes or no? So total energy is what? The total potential energy plus total kinetic energy. Now guys, let us take again the same example. Suppose if a body is freely falling body, I can say freely falling body. Okay, now this is a body which is freely fall to the ground, okay, from the height h. Yes or no? This is the height h. So I can say the energy is conserved. I mean the total potential energy or total mechanical energy, which is nothing but the potential energy plus kinetic energy, must be conserved. So okay, I know here the potential energy plus kinetic energy here is same as any point, okay, or here also potential energy plus kinetic energy. So I can say the energy is conserved, guys. What is the meaning of conservation of energy? So conservation of energy means what? Energy neither be created nor be destroyed. It can be transferred from one form to another form. Okay, so if you find what is the velocity, I mean here velocity is simply, what is the velocity? You tell velocity equal to 0. So if velocity is 0, what about the kinetic energy, which is equal to half mv square? So half mv square is equal to 0. This is the free fall body, guys. This is free fall body. Okay, and only force is acting here is what? Gravitational force. Okay guys, only force acting here is the gravitational force. Okay, so here the distance is what, h, so I can say the kinetic energy here is what, mgh. So let this is the point A, this is point B. So at point A the kinetic energy is equal to 0 because velocity is equal to 0, but at the same point potential energy is equal to mgh, or I can say this is maximum. Yes or no? Because the height is at h. Now if I coming down to the point B, so if the body is freely fall, since the body is freely fall, so near just above the ground the velocity is maximum. So here velocity is maximum. So what about the kinetic energy? Is obviously maximum because the kinetic energy depends upon V. Now what is the height here? Height is 10 to 0 or near about 0. So kinetic potential energy here is 0. So here I can say kinetic energy is maximum and potential energy is 0. Yes or no? So in each point I can say energy is conserved. It means what? Total mechanical energy at each point is same, which is total kinetic plus potential at any point you find is same. So here one formula I can write here, that you find potential energy here is maximum A point. So I can write potential energy at point A is maximum is equal to kinetic energy at point B maximum. Okay, so you should remember this formula as well guys. You know, sometimes what happens, the only kinetic energy is given to you, or it is asked to find the potential energy at some height h. So you need not have to find mgh, you can easily find half mv square kinetic energy, which is same as the potential energy. Okay, yes or no? So let us solve some problem, you can able to understand that. Now let us solve one first question. If here the body fall freely, now let us take this is the body fall freely. Yes or no? Now the body of mass is equal to 0.2 kg. Mass is given what? 0.2 kg. Okay, and the height is given what? 5 meter. The question is find the kinetic energy at the this point, or near the ground. So here the velocity is not given to you. Yes or no? So how will you find? Now by using this equation guys. This equation will help you to find the kinetic energy. Now what is kinetic energy here? So kinetic energy nothing but the potential energy. Potential energy here is equal to kinetic energy here. So I know I can find mgh. So m is given 0.2 kg, g is what? 9.8, and h is what? 5 meter. Will get the answer. Yes or no? Now let us go for another question. A body throw from the ground to its highest point. Now let this, there is a body, it is throw from ground to the highest point. Let this is the highest point, okay, whose height is h. Now the body is thrown with a velocity v is equal to 2 meter per second. Suppose the velocity is given and mass is equal to 0.2 kg. Okay, the question is find the potential energy at the highest point. So similarly we follow the same equation. Yes or no? The potential energy here is same as the kinetic energy here because the energy is what? Conserved. Yes or no guys? So I can find easily half into mv square, which is nothing but the potential energy at the highest point. Yes or no guys? So these are some questions. Let us solve one more question so that you can understand it the better way. Now suppose a body thrown from or freely from fall from a point here. Now this is the situation. Okay, now let this is point A, this is point B, this is point C. Here the height is given what? X. From A to B, and from B to C the height is given what? Y. Okay, so question is find the potential or total mechanical energy at point A, B and C. So you will have to find the energy at A, B and C. So at A, okay, so what is the height at A? So h is nothing but x plus y guys. Yes or no? What is velocity at A? Here 0. So velocity 0 means what? Kinetic energy is equal to what? Half mv square, which is equal to 0. So here only potential energy exists. So what is that? Is nothing but mgh. So what is m into g? What is h? X plus y. Yes or no guys? As I told you that the potential energy or the total mechanical energy at each point will be constant because of the conservation of the energy. Yes or no? Now at point B, this is what the total energy, kinetic plus energy here at point A. Let's see what is the what is at B. So at point B I can say at point B. At point B, what is the height from the ground is what? Y. So what is the potential energy? I can say m into g into h. What is h is? What is h here guys? Y. So this is mg, y is the total potential energy. Now the here velocity is not given to you. So let here the body falls from A to B with a velocity v. So I'll use the equation of motion. So b square equal to u square minus 2as plus 2s. I'm sorry. So here the initial velocity is 0. So I can write v square equal to 2 into what is equal to g into what is s. Distance is what? X. So 2gx. So what is the kinetic energy? Is nothing but a half into m into b square. Yes or no, guys? So this is half into m into b square. What is b square? Equal to 2gx. So 2 into g into x. So here 2 to cancel. So this is mgx. So what is total mechanical energy, guys? Is what the potential energy plus kinetic energy. So take mg constant. If I'll take mg constant, you'll get x plus y, which is equal to at the point A. Yes or no? Now let us see, find at the position C. Now at C, what at point C, what is the H is equal to? Is 0 simply. So what is potential energy is equal to 0. But what is kinetic energy here, guys? So same thing here also. Let us take the equation. What is the distance from A to C is what? Distance or displacement, I can say S is equal to what? X plus y. Yes or no? So use equation of motion. So b square equal to u square plus 2as. Let the velocity is v. So initial velocity is what? 0. So v square equal to 2 into g into what is s? X plus y. So what is kinetic energy, guys? Half into m into b square. So half into m into what is b square? 2g into x plus y. So your 2 to cancel. So mg into x plus y. From this example, it is proved that, guys, that at each point the energy remains what? Same. Yes or no? So these are the some examples we have solved. In our next video, we'll study some more examples of kinetic energy along with the different forms of energy. Thank you.